Welcome to Ask and Learn.
Problem, we have an escalator that has a velocity of 0.6 meters per second, and we know that the height of each individual step in the escalator is 0.125 meters. The length of each little step is 0.25 meters, and we know that in total there's 32 steps. We'll say n, we'll call that n. And we want to find the power necessary to lift somebody that has a mass of 150 kilograms. Since we're dealing with power, we know that power is equal to force times velocity. But here the velocity is actually in the y direction, right? Because the velocity is going up the escalator. So we know that these have components, right? We have v of x, and in the y direction we have vy. So to find vy, you can say sine theta is equal to vy over v. So then vy is just that velocity times sine theta. Now let's plug this back in for power. So we have power is equal to force times velocity times sine of theta. So to find a value for sine of theta, we need to know the dimensions of the escalator. So this escalator, again, creates a sort of triangle. So we know at the bottom, it's the length of each individual step times how many steps there are. So we know we have 32 steps times the length of each step. And for the height, we know, again, it's the number of steps times the height of each individual step. So then to find the hypotenuse, which we'll call z is equal to 32 times 0.125, and of course this is squared, plus 32 times 0.25, and this is also squared, and of course take the square root. So for z, we know we have 8.9 meters. So now that we found z, we know we can say sine theta is equal to the height. So 32 times 0.125 is actually 4. So we have 4 divided by the hypotenuse, 8.9. So now let's plug this back in for our equation for power. So power is equal to the force, and the only force here is just the weight of the person, and that weight is going to be traveling through each step. So it's 32 times the weight of that person, which is the mass of the person, times gravity, 9.8. And then this is times the velocity, which we know is 0.6 times sine theta. And now we know a value for sine theta, which is 4 divided by 8.9. So then the power necessary for the engine to generate for this escalator is 12.6 kilowatts.